Okay, so day one, introduction to matrices. So what is a matrix? So a matrix is a set of data and it's arranged using what we would call rows and columns. So when we talk about a set of data, this right here is what we call matrix notation. They use these little brackets, and we have going across here, we have our rows, and going down, we have columns. So when we talk about the dimensions of a matrix, the size of a matrix, because they could be different sizes of whether I'm looking here or here, they could be different sizes. So we call that the dimensions of the matrix. And the dimensions are always going to be the number of rows by the number of columns. So it's rows by columns. So when I look here, this particular matrix, this has 1 row, 2 rows, it has 3 rows. So we say that the dimensions are going to be a 3 by, and I count my columns, it has 1, 2, 3, 4, 5. So we say that this matrix is a 3 by 5 matrix. So when it says, what is the size of the matrix? We would write it like this. We would say it's a 3 by 5. Each of these values within the matrix, each one of these numbers here, each one of these is what we call an element. It's called an element. Each one of these values in here is an element. So if we wanted to see how many elements there are in here, there would be 3 times 5, 3 by 5. There'd be 3 times 5. In this case, there are 15 elements within this matrix. So again, these are the values in the matrix. So if I go down to this problem right here, if I go down to this matrix, if I wanted to figure out what the dimensions are, if I looked at my dimensions, again, the rows by columns, rows by columns. Oops, did I go off the paper? I did. So in this case, there's 1, 2, 3, 4, 5 rows. There's 1, 2, 3, 4, 5 columns. So this is a 5 by 5. When you have the same number of rows as you have columns, this has a special name. This is what we would call a square matrix. This is called a square matrix because it has the same number for each side. It forms a square. Pretty obvious there. Pretty straightforward. Okay. Well, then it says, in matrix T, what is the value of elements? Remember, each one of these numbers is an element of T1, 3. Well, what is this 1, 3? Well, just like we talk about the dimensions, it's rows by columns. These numbers here for the elements are talking about my rows and columns. So this is saying row 1, and this is saying column 3. So if I want to know what element T1, 3 is, I would go to my row 3, or sorry, my row 1. So it's going to be, here's my row 1. That's my row 1. But I want to look specifically at column 3. So at column 3 is this value of 7. So that element is going to be 7. That element is going to be 7. And this is interesting because this table represents time spent making phone calls. So the rows represents the person calling, the columns represents the person called. So I can ask a specific question. Oops, I didn't admit. Hopefully she wasn't waiting. Let me turn my volume up. Okay, so I can ask the question, how many minutes did caller 3 spend calling caller 4? Okay, so again, it says that the Rows represent the person called. So the caller, the person who's calling, the caller is in 3. So we're talking about our 3. So we're going to be talking about element. We're talking about our 3, caller 3, and it's calling 4. So we're talking about 3, 4. So I'm looking here, we're talking about the caller, the person calling was here, and they called person number 4. So this would be my element 3, 4. So this would be 52 minutes. That's how long they were on the phone. So this table can represent information just in a more of a confined space instead of having it all jumbled out. You can just put it all into one organized method. And so that's why we use matrices, kind of almost like an Excel format, and you could put them in its own little boxes. So the answer for this would have been, sorry, 52. Oh, I didn't realize I typed it out right there. Oops. Okay. So moving on. So we've seen how we could put some of the data into these matrices, and we talked about using information, like we could be collecting data, whether it's a survey or the number of minutes from these phone calls, or we can use linear systems. And that will come up a lot in this unit where we're talking about these linear systems. And what I can do is I can take these values here, our linear system, and I can write it as a matrix. So this would be my row 1, and this would be my row 2, equation 1, equation 2. And so here's how that would look. If I have my row 1 and my row 2, I would have a 3, 7, and my 20. Looks kind of funny, right? That's because this first column represents the x values, my y values, and this is that solution. So when I talk about my second equation, I would have a 1 here, then I would have a -4, and it's equal to this 9. So a lot of times you'll see this little dashed line to represent that this is going to be what we would call the coefficient matrix. So again, the coefficient matrix are the coefficients of the values over here, and then this is what it's equal to. This whole piece is what we call an augmented matrix. So always a lot of vocabulary right at the beginning. If you want to talk about just this piece right here, this is the coefficient matrix. So you can take a linear system and you can write it as this whole piece where you have the solutions, and that's the augmented matrix, or just the coefficients. So it says identify the values for the elements in each of the coefficient matrix. So here's where these values are. So my A11, row 1, column 1 is 3. A12 is this 7. A21 is this 1, and A22 is that -4. So those, all you need to do is fill in those values. So they were 3, 7, 1, and -4. Of course, if I go too fast or you guys have questions, please let me know. This is just kind of introducing some vocabulary, just how things are set up. It's pretty straightforward today. I only have one more example for you guys. So this is just going over the instruction, and we'll start assignment next week. So, which of the following matrices are equal? Which ones of these are equal? And the only ones that are going to be equal is this one and this one. For them to be equal, they must have the same dimensions. If I could spell dimensions, and corresponding elements. There's no exception. They have to have the same dimensions. Well, some of you guys go, well, wait a second. If I look at this one, let's see. Like if I look at these, they have the same values. I could have taken this, and if I switched it and said, oh, like this one right here, And so these are 0, 1, or 0, 1, and have 1, 0. And you're like, well, I'm just kind of turning it. That's okay to turn it, but they're not equal. Like you can have a matrix that's set up like this, but these dimensions, remember the dimensions of this one's going to be a 2 by 3, and the dimensions of this one is a 3 by 2. So these dimensions are not the same. They're not the same. They have the same values and it's turned, but they're not going to be able to represent the same data. I can have a matrix that looks like this, but it's not going to represent the same set of data. And so they cannot be equal. I can have the same shape, the same dimensions, so I can have this as a 2 by 3, and they can have the same dimensions, but that does not make them equal, because for them to be equal, not only do they have to have that same dimensions, but the exact location. So this 0 here would have to be the same as this value here. So at 1, 1, row 1, column 1 would have to have the same value, and that is not the case. So only these two are equal. They have to be identical for them to be equal. And so that was kind of, just wanted to make sure to emphasize that with this problem. That's all I have for you guys today. If you have questions, please reach out. Report cards are going to be coming out. Grades are going to be due. So make sure if you have any catching up you need to do. I'm putting in grades on Monday. The grades that are updated on Monday are the grades going on report cards. So third quarter grades, already to third quarter. Done with third quarter almost. So you guys have a great weekend, and I will see you next week.